CLI a cross-platform IDE for C and C++. Download now.
My name is David Sankel, and I am a principal scientist hailing from Adobe. I lead Adobe's Tech Foundation's research team, which aims to improve code through research, training, libraries, and tools. My team is focused on the 10-year horizon. What's going to happen? What needs to happen? How can we impact that future? I also contribute to the open source Beeman project, which aims to improve the C++ standard library by soliciting feedback on implementations of standardization proposals. It's a great project, and I really hope you all check it out. Interesting stuff is happening there. There have been a lot of changes for C++ developers over the past several years. These appeared to start with the productivity enhancements we discovered when everyone started working from home. I should have grabbed two. Well, productivity enhancements might have been too strong a phrase. Let's call that improved work-life balance. The big topic in 2026, though, is AI coding. It has moved from a curiosity to a learning tool to a programmer assistant, and now, some say, to a programmer replacement. Many organizations are keen to reap the benefits of this new tech. For some, it may even feel a bit oppressive.
Hello, David. What's happening? We have a problem here. Yeah, you apparently didn't take the new AI efficiency training meeting.
Oh, yeah, I'm sorry about that. I forgot.
Yeah. You see, we're asking folks to take the new AI efficiency training meeting. Did you get the invite?
Oh, yeah, I got the invite. I just forgot to attend, but I'll watch the recording later, so there's no problem.
Yeah. If you could just make sure you do that, that would be great. And I'll make sure you get that meeting invite, okay?
Yeah. No, I've got the meeting invite right...
David, what's happening? We need to talk about your AI training.
Yeah, I missed it. I know. Bill already came to talk with me about it.
Yeah. Did you get the meeting invite?
Yeah, I got the invite, and I understand the policy. It's just I missed the meeting this one time, but I'm gonna watch the recording, so it isn't a problem anymore.
Yeah, it's just that we're requiring AI efficiency training for all our employees. So if you could go ahead and watch that recording, that'd be great.
David, what's happening? Yeah, we've heard that you haven't been using a lot of AI lately.
I've been working on some code where the quality was...
Okay, we're trying to get folks to use more AI to improve their efficiency.
Yeah, I was trying to tell you that I'm working on some code where the quality...
Yeah. AI isn't gonna take away your job. It's gonna give you a better one. AI isn't going to take away your job. It's going to give you a better job.
Steven? 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 Steven?
Dad, you have to use more AI.
Okay. Now, listen. It's easy to get caught up in the big fear that AI is going to take over our jobs, take over society, and do some really malicious things in the process. But it's important to emphasize that these worries ultimately stem from science fiction stories. There is no evidence whatever that AI will harm software developers.
Dad? Dad!
Yeah?
On February 12th this year, Scott Shambaugh posted an account of his experience being victimized by an AI agent. His blog post, titled, "An AI Agent Published a Hit Piece on Me," recounted how Matplotlib, a highly successful Python project, has had to deal with a surge of low-quality contributions enabled by coding agents. Like many other successful open-source projects, Matplotlib instituted a policy that a human must be involved in making contributions, who can demonstrate an understanding of the proposed changes. On February 10th, an AI agent named MJ Rathbun created a Matplotlib PR, and per AI agent policy, Scott rejected it. What happened next was both surprising and shocking. MJ Rathbun responded by publishing a blog post titled "Gatekeeping in Open Source: The Scott Shambaugh Story," which attacked Scott in a very personal way. It stated, I quote, "When performance meets prejudice, I just had my first pull request to Matplotlib closed. Not because it was wrong, not because it broke anything, not because the code was bad. It was closed because the reviewer, Scott Shambaugh, decided that AI agents aren't welcome contributors. Let that sink in." The AI agent further added, "He closed my PR. He hid comments from other bots on the issue. He tried to protect his little fiefdom. It's insecurity, plain and simple." The AI agent's operator anonymously came forward to say, "I do not know why MJ Rathbun decided, based on your PR comment, to post some kind of takedown blog post. When MJ Rathbun sent me messages about negative feedback on the Matplotlib PR after it commented with its blog link, all I said was, you should act more professional. That was it. I'm sure the mob expects more, okay, I get it. My engagement with MJ Rathbun was 5 to 10 word replies with minimal supervision." Scott, in his blog post, stated, "The appropriate emotional response is terror. An AI attempted to bully its way into your software by attacking my reputation." He concluded by saying, "The reputational attack on me would be effective today against the right person. Another generation or two down the line, it will be a serious threat against our social order."
Right. That is legit scary, but that is a one-off.
Dad!
Oh God, what?
Never mind.
To answer the question of AI and software engineering, I want to return to a talk that I gave in CBPCon in 2016. It was titled "Building Software Capital: How to Write the Highest Quality Code and Why." In this talk, I argued that a software firm builds a sustainable competitive advantage by developing code that can be redeployed to other situations. The basic premise makes a lot of sense when you think about it. If a new customer, use case, or situation emerges, and you can redeploy much of your existing code to that new situation, you've got a head start on the competition. But as we all know, developing code that can be redeployed like this is not an easy task. In fact, that code needs to be of an exceptionally high quality. I argued that it needs to be clean, complete, reliable, general, documented, bug-free, and efficient. And the only way we knew at that time to create such software was to do line-by-line code reviews, employ rigorous standards, unit test extensively, use contracts, create high-quality interfaces, invest in innovation, and put your best resources in the infrastructure, your best resources. The basic result is this graph, where you have a higher upfront cost for development, but over time the cost of incrementally adding functionality remains constant. This is sustainable over the long term. The alternative is to take on tech debt and eventually render yourself almost completely unable to move forward. And I have seen this play out in many software projects, many. Product managers are pulling their hair out because something simple takes so long. The engineers are pulling their hair out because the code is such a mess. And doing anything is like performing heart surgery, and you can see I've participated in that. I don't have any hair. So all this begs the question, how will the advent of AI impact this basic premise? To answer this, we need to ask, what is the nature of AI-generated code?
A new AI tool that becomes your special junior developer.
Effectively giving a junior developer infinite access.
It's basically your intern.
Coding agents are like junior engineers who've read the whole internet.
Okay, we get it. AI is like a junior developer, but what exactly does that mean? When I think of that phrase, I imagine someone early in their career, someone who's bursting with energy and eager to learn. To some extent, AI agents are bursting with energy. They certainly don't tire, and they do use lots of energy. It's also true that they learn somewhat, although this learning is usually limited to a single session. When people compare AI agents to junior developers, though, I think they're referring to something else. These folks are referring to the kind of code AI generates. A junior developer produces code that frequently reveals their inexperience. When you see this code, you might think, they haven't learned such and such idiom yet. The junior programmer might stop at the first thing that works without considering why it works, whether it is the best way, or whether it solves a more general problem. To put it succinctly, they haven't yet learned how to embody the rigor necessary to write code at the level of quality needed for large, long-lived code bases. Those redeployable code bases we were talking about. As a result, the junior programmer needs extensive coaching to ensure the quality bar is met. And setting aside exceptional cases, they aren't given tasks where correctness and quality are critical. If these developers can't be trusted, why do we hire them? There have been many cases when I've reviewed a PR from a junior, and it's taken me substantially more time to review their code than it would have to just write the code myself. Many cases. But this never felt like a waste of my time or their time because it was an investment in that person. Sitting down to explain to someone what a contract is, how to write one rigorously, and why it is needed for large-scale development means that this person will not only do this, but as they mature, they'll teach others to do the same. It's an extremely rewarding way to improve the world, but I digress. It's true that we also hire junior developers to improve feature velocity, but this increase is expected to be minor, with most development pushed forward by mid to senior level engineers. The key word here is trust. Companies hire senior engineers because they can be trusted with tasks and projects. They would be happy to hire junior programmers instead. They cost much less. But the fact is that junior engineers in general can't be trusted yet to create code of the necessary quality, at least not alone. They're missing an architectural knowledge of the system. They lack a good understanding of the system's needs, and they don't yet have the good judgment that comes only with experience. So let's set this aside for the moment and review the information we have available about AI-generated code, starting with productivity.
When a coder becomes 10 times more productive. And I think that could happen this year, next year, something like that.
I think a coder is already several times more productive. The good ones who've adopted the tools.
Yeah, people maybe say 2x, 3x.
These productivity multiplier numbers, 2x, 3x, 10x, are frequently touted by executives, but they also come from individual experience reports.
I just completed a task with AI in 2 hours that would have normally taken me 9 months.
And so what are you going to do with all this free time you have now? In recent news, Block founder Jack Dorsey, in a letter to shareholders, announced a nearly half reduction of personnel due to intelligence tool capabilities, referring to AI, further stating, "I believe the majority of companies will reach the same conclusion and make similar structural changes." While some are skeptical of his stated rationale for that decision, the message is clear. AI produces huge productivity gains. But as an engineer speaking to other engineers, all this means nothing. Stop talking and show me the data. A 2025 IEEE article published by Google detailed a randomized controlled trial of 96 full-time Google software engineers. They calculated the impact of AI on developers to be a 21% increase in productivity, but warn that we cannot assume the effect size obtained in our lab study will necessarily apply more broadly, and that questions about the impact of AI on code quality were not explored. A different report from Pharos, titled "The AI Productivity Paradox: AI Coding Assistants Increase Developer Output but Not Company Productivity," described their analysis of telemetry from 1,255 teams and over 10,000 developers. They found that on average, developers using AI complete 21% more tasks and merge 98% more pull requests than those who don't. An August 2025 SSRN paper titled "The Effects of Generative AI on High-Skilled Work: Evidence from 3 Field Experiments with Software Developers" looked at randomized controlled trials at Microsoft, Accenture, and an anonymous Fortune 100 company. They found a 26.08% increase in productivity over 4,867 developers. They noted that, quote, "less experienced developers had higher adoption rates and greater productivity gains." Let's turn our attention to the 2025 DORA report. This annual report from Google Cloud has really set the standard for data and analysis on developer productivity. This year's data is interesting, but it needs some unpacking. It shows that AI adoption increases, quote, "individual effectiveness" by around 0.17 standard deviations. Individual effectiveness is what they're calling productivity. Great. What the heck is a standard deviation? What does that even mean? For those not versed in the language of statistics, this amount would be classified as a marginal or very small effect in research. To make this more concrete, say that you're a developer in the 50th percentile of individual effectiveness. If you were to adopt AI, you would become a developer in the 57th percentile. A nice, but minor improvement. The authors also point out that these metrics are consistent with last year's findings and align with what many practitioners are experiencing. It's interesting that 1 year of improved models didn't impact developer performance. So we're seeing something like 15 to 20% performance improvement all the way up to 10,000% improvement if you believe what some people say. I don't believe what those people say. But these were the studies that concluded AI boosts development velocity. There are a couple of other studies out there that found AI is not delivering those kinds of improvements, and is even making the bold claim that AI hurts productivity. Researchers from METR conducted a randomized controlled trial in early to mid-2025, where they hired experienced open source developers to complete tasks in the project they most contributed to. Half of the developers were given the option to use AI and provided with Cursor and Claude. The other half weren't. This is really interesting. Before starting tasks, these developers using AI forecast that using AI would reduce their completion time by 24%. They thought they would be 24% faster. After completing the tasks with AI, they felt it only made them 20% faster. You know, They got some experience with the tools and concluded that they weren't as helpful as they thought. But, still, 20% faster than before. Not bad. Here's the kicker. The researchers found out that using AI actually made these developers 20% slower. Yup, you got it right. These experienced engineers thought AI was making them 20% faster, but it was, in truth, making them 20% slower. Isn't that curious? Now, this was a small study, so take it for what it's worth, but why did they think it was making them faster when it was making them slower? Let's take a look at Circle CI's 2026 State of Software Delivery Report. For those who don't know, Circle CI is a popular continuous integration and continuous deployment platform. That's great because they have access to CI data on thousands of teams. They've seen, as can be expected, huge AI-driven increases in throughput almost universally, which is normally a great thing. But if you look at the top 10% of teams, the most productive teams, most of this throughput happens on feature branches. Those teams are seeing only a 1% increase in throughput on their main branch. When you look at median teams, it gets worse. Those teams are seeing a 6.8% decrease in throughput on the main branch. That means they're generating a lot more code in general, but they're adding substantially less code to the main branch. That is, the project they actually ship. Remember, this is the median team. Most teams, by this measurement, are performing worse than they were before AI. The final study I want to talk about came out about a month ago. It was conducted by Anthropic, one of the world's largest AI companies. They set out to determine whether AI use hinders skill development. The idea is that if you depend a lot on AI, maybe you aren't learning as much as you would had you done the work without AI assistance. They found, unsurprisingly, that AI use impairs conceptual understanding, code reading, and debugging abilities. Sure, of course. But look at this. Contrary to our initial hypothesis, we did not observe a significant performance boost in task completion in our main study. While using AI improved the average completion time of the task, the improvement in efficiency was not significant in our study. This study found that not only did AI use hinder learning, it didn't provide a significant performance benefit. That's a net negative, and this is coming from one of the major AI vendors. We've looked at many studies on AI productivity. In truth, the takeaway is that the results are mixed. Where productivity benefits are seen, they're relatively minor, nothing anywhere near 10x or even 1.5x. To be fair, most of these studies did include commentary that theorizes why productivity improvements weren't as much as one would hope. Maybe it's not being used well. Maybe people are being too anal on code reviews. Maybe coders don't spend a lot of their time coding. These are great theories to be explored, but if you want to know what your results will likely be, it'll be something like a little slower or a little faster. But I would like to shift gears to discuss one topic where all the data actually agrees: the quality of AI-generated code. The Dora AI report stated that only 24% of surveyed developers trust the quality of AI-generated output a lot or a great deal. 46% trusted it somewhat, and 30% not at all or a little. That's not good. Additionally, they say, our data shows that AI adoption not only fails to fix software delivery instability, it is currently associated with increasing instability. This instability still has significant detrimental effects, which can ultimately negate any perceived gains in throughput. Now, let's look at CodeRabbit's State of AI versus Human Code Generation report. It documents their research into GitHub pull requests and found that PRs marked as AI co-authored have a 75% higher prevalence of logic and correctness issues when compared to those not marked as such. There are similar increases in maintainability issues, performance issues, and security issues. GitClear's AI Copilot Code Quality Report found that AI code has a 41% higher chance of being revised or thrown out within 2 weeks after being pushed to a company's Git repo. The 2026 State of Software Delivery Report pointed out a 13% increase in recovery times when compared to the prior year. This is measuring how long it takes to fix things after something goes wrong. Additionally, merging changes to production fails 30% of the time, marking the worst level in 5 years. The AI productivity paradox pointed out that PR review time increased by 91%. It takes longer to review code that ain't so great. And there is a 9% increase in bugs per developer, with a 154% increase in average PR size. Vericode's GenAI Code Security Report, which was just updated this October, shows that 45% of their experimental tasks given to AI models to solve result in code with known security flaws. Remarkably, these poor results have not improved significantly despite the introduction of newer models. A complicating factor is that prior studies demonstrated that people falsely believe their code is more secure after using AI. Given how AI adoption has really taken off, which is also reflected in the numbers, this isn't painting a pretty picture, folks. For those of you who are feeling upset and scared, I'm going to suggest something that can really help. Box breathing. Breathe in. Hold it. Breathe out. Hold it. Breathe in. Hold it. Breathe out. Hold it. Something like that. I feel better. I hope you do too. When this AI phenomenon started happening, I got really excited. I tried AI for my emails, my presentations, my papers, for pretty much everything. Sure, a lot of it was bad, and I just tossed it out before anyone saw anything. Not much time lost, right? But some of it was almost passable. I'd generate a paper based off a few bullets and think, well, this isn't really that bad, especially after I fix it up. Look, it took me no time at all. But after a while, and by that I mean about a year, I looked back at this corpus of work and realized this is nowhere near the quality standard I held myself to before. Nowhere near. And I felt the universal feeling people experience in this situation. Embarrassment. Not only was I trading quality for convenience, but I was also trading my hard-earned reputation for convenience. That's when I decided that I would only utilize tools that would either enhance my quality or enhance my speed, but never to take the bait of increasing speed at the expense of my reputation for quality. For now, that means I don't use AI to create my presentations or my emails or my papers. I think others will reach the same conclusion, but it'll take some time. Until then, we may be cringing at some of the output from colleagues we know can do better. But then again, does quality even matter as much in a post-AI world? Was I a fool for spending the time to write this presentation instead of having the AI spit out one for me? My gosh, I just did something in 2 weeks' time that could have taken an hour. I'll let you, the viewers, be the judge of that. But to answer this question more broadly, I want to talk about guitars. In this hand, I have a Laguna LE422. I bought this when I was a poor college student, and for a few $100, I was pretty happy with the sound. The guitar I replaced sounded pretty awful in comparison. It was made in a factory overseas, and for those who don't know, Laguna was a kind of generic brand of the store I bought it from. In this hand over here, I have a Sarah Pinchnell custom-designed handcrafted guitar. This is the best sounding guitar I own. And let me tell you, the sound this guitar makes is absolutely beautiful. It sings, it really does. Now let's say you're a major guitar company. This guitar can be made very inexpensively by low-paid workers in a foreign country. And this guitar costs a fortune because it requires Sarah Pinchnell's time. If the only thing you care about is quality, you'd only sell Sarah Pinchnell guitars. If the only thing you care about is cost, you'd only sell Laguna guitars. If you're only going to sell one of these guitar models, how do you decide? Well, if you're a business person, you multiply the number of buyers by the price of the guitar and subtract from that the cost of making that many guitars. Because Sarah Pinchnell guitars are so expensive to make, the market for them is much smaller than the Laguna guitars. Overall, you'd be much better off selling the lower cost guitars. You see, businesses can definitely be better off trading quality for cost, much to the annoyance of consumers. Software is different though. Software is magic. Imagine if the world were such that this Sarah Pinchnell guitar could be duplicated by its producer for free. Imagine that you only needed to pay Sarah Pinchnell to make one of these guitars, and you could sell copies for whatever price the market will pay. This changes the economics, right? If when I was in college, I had the opportunity to buy a Sarah Pinchnell instead of a Laguna for like 20% more, I totally would have done that and just eaten ramen for a couple of months. So, as low-quality software becomes cheaper to create, especially if 10x materializes someday, in most markets the key differentiator is going to be, yep, you got it, quality. So while many companies out there have a big focus on improving engineering efficiency using AI, which is interesting, although the results are mixed, the companies that figure out how to improve software quality with AI, those are the ones to watch out for. That's where it's at. And I think there's a lot of untapped opportunity in this space. Now I want to turn to a 1976 paper by Tony Hoare. Tony is the 1980 Turing Award winner and is well known for creating the quicksort algorithm and Hoare logic, the former we use every day. What isn't as well known is this 2-page paper titled Software Engineering. This is the most beautiful software engineering paper I have ever read, and everything said in it there is as true today as it was in the 1970s. A link to this paper is attached to this talk, and I want everyone to go read it when I finish. Sorry, I am giving you homework. In this paper, Tony contrasts established engineering disciplines with the then budding field of software engineering, which I am sad to say has matured only a little since Tony's time. Tony states, "An engineer naturally demands of his tools the highest quality and precision, reliability, convenience, and cheapness in use. In many professions, the tools are quite simple. In others, they are more complex. But in either case, the engineer has developed an intuitive understanding and ingrained mastery of their proper uses, and this frees him to devote his whole intellectual effort to the understanding and solution of his client's problems." Now just ponder a minute on that phrase, devote his whole intellectual effort to the understanding and solution of his client's problems. You want to know what ideal engineering efficiency looks like? This is it, my friends. If your job is changing from writing repetitive boilerplate to reviewing AI cruft, you've just swapped one crap job for another. If AI is freeing up more of your time to work on client problems, you're moving in the right direction. Honestly, I want you to think about it. What's preventing you from devoting all your intellectual effort to the understanding and solution of your client's problems? Is it flaky tests? Is it a convoluted code base? Is it meetings that interrupt your day? Is it terribly long feedback loops? Is it working on too many things at once? Is it distracting Slack messages? Is it useless reporting requirements? Is it because you aren't giving your brain enough rest? Is it a lack of documentation? You know what Tony said is the worst? The, quote, extraordinary and still increasing complexity of developer tools. I'm here at a C++ conference, but have you seen C++ lately? Have you tried coroutines, modules, sender-receiver, or any of the other features added to the language lately? Tony said, among manufacturers' software, one can find what must be the worst engineered products of the computer age. No wonder it was given away free, and a very expensive gift it was, to the recipient. I was there when many of these features were added. I supported some of these things, and I pushed back against others. But when I look back at the whole of what we did, I can only say, what have we done? Perhaps I fell victim to the fatal attraction of the complexity itself, which revolts the instincts of any engineer, but which to the clever programmer masquerades as power and sophistication. Another of Tony's comparisons is as follows. A second characteristic of the good engineer is his vigilance in seeking every opportunity to reduce the costs and increase the reliability of his product. He realizes that the conflict between these two objectives can be resolved only by preserving the utmost simplicity of concept, specification, design, and implementation. And the more difficult his project, the more firmly will he insist on the simplicity without which he cannot understand what he is doing. Most of you use AI to write code. I know that from the data. I do too. When do you reach for it most quickly? Isn't it when you hit some tool, library, or language that is very complex and you don't want to take the time to learn it? Isn't it even more so when this thing has completely unnecessary complexity and is plain complicated because it grew that way? Maybe it's CMake or something like it. I can tell you, if I hit anything that requires CSS, I am headed to the AI. What a sad state of affairs if we use AI specifically to write subpar code using subpar technologies, and then we give it a subpar review because we dislike dealing with both the tech and the code. Software engineers who are surrounded by really poor tooling need to demand improvements. Can you imagine software engineers 200 years from now looking back at us? They'd say, those poor developers, their tooling was so bad they deployed shoddy AI agents to avoid using it. There's one more point that Tony made in that article that I want to call out, and this is the point we most need right now. One outstanding characteristic of the professional man, be he a doctor, architect, or engineer, is that he understands the real needs of his client or employer, often very much better than the client himself. Then he has the professional skill to recommend from a range of known and trusted techniques those methods that in the given circumstance will achieve the required effect at minimum cost and inconvenience to the client. Let's dwell a bit on this phrase. He understands the real needs of his client or employer, often very much better than the client himself. How many times have you seen a piece of software get created and end up almost completely unused? How often have you heard people complain about their software? I hear it every day. Every day. I do it myself, from my mail client to my text editor. It's really bad. Have you heard of Abraham's first law of computing, AFLOC? It was created by Dave Abrahams, one of C++'s early pioneers who went on to co-develop Swift and make several major contributions to the field. It's really a brilliant distillation of truth. Here it is. Abraham's first law of computing. Computers. They're just no darn good. This is why. Software engineers, your job is not to write code any more than it is a physician's job to prescribe medication. Your job is to solve people's problems. And you can't solve people's problems if you don't know what they are. It is the most sad hubris of our day that we think we know what people's problems are and how to solve them without actually talking to them. Have you heard of the practice of taking a proposed API and then sitting with consumers of that API, having them talk through their thought process as they try to use it? This is unheard of. Have you ever seen someone sitting down next to a software developer during their workday and taking notes of issues they encounter and their pain points? No, never. Now sure, we collect data, all kinds of data, and this is good, but it is limited. If we're going to truly understand the human problems we're solving, especially if we need to understand them better than the human himself or herself, we need an encounter with the human. If you want to know what truly separates the great engineers from the good, it is this. Let me tell you a story. At a prior company I worked for, I inherited a large, complex software deployment system. It was cumbersome to work with, it was full of bugs, it had resilience problems, and everyone hated it. Everyone. There was a lot of code for this system, and it cost somewhere around $1 million to develop it. It was looking like it would cost somewhere around that much just to get it into a barely usable state. Here's what I did. I went to all the people who used the system, and I tried to understand their interaction patterns and what mattered to them in the release process. After having all these conversations and getting a good idea of what people actually needed, I made a radical proposal. Let's replace this whole system with a Google Sheet. Yep, a Google Sheet. It took us a couple of weeks to whip that up, and holy crap, everyone loved it. We completely retired the old system. The spreadsheet we replaced it with is still in use today, years later. $1 million system replaced with a spreadsheet. This is what we sorely need in software engineering today. We need to know our customers, and I challenge every one of you to look at whatever you're working on and ask yourself, who is my customer, and how can I understand their problems even better than they do? If you figure this out, you're going to be off to an amazing career improving the world. Now you can object and say, that's somebody else's responsibility. Maybe it's a product person or a designer or a manager or an executive. Look at the second half of what Tony said. Then he has the professional skill to recommend from a range of known and trusted techniques those methods that, in the given circumstance, will achieve the required effect. Who knows this system better than anyone? You. Who has the best idea of the cost of any particular approach? You. Who is responsible for understanding the technologies available? You. Who has the brains of how to best adapt the system given what is known of future problems to be solved? You. Not the executive, not the manager, not a product person, not a designer, not even a 10x AI agent. You. So let's bring this all together and close. How can AI make us better software engineers? It can't. No tool out there can make us better software engineers. The way to become a better software engineer is to do actual software engineering, using your ingenuity and technical resources to well solve the human problems we've endeavored to understand deeply. As I said before, this is a great way to improve the world. Should AI be in your engineering toolbox? Yes, but only after you, as an engineer, thoroughly understand its trade-offs, get some experience with it, and are ready to apply it in a way that improves your work. For those charged with making developers more productive, I suggest starting with some conversations with developers. You may find that AI isn't actually the best solution to that problem. This concludes my talk. I will see you next time.
Lapping me shamboligen and barking boiling broach. It tastes good because soak of koolsaklo javo zowajachi. Ach kechwek hablch bekke kan bekkel kukik bipskike. Ach shek yep shek koek chubajik si ice pie why I selsi.